Welcome to my science tutorial. In this video, we'll be talking about hydration and hydrolysis. You've probably heard about these themes in your lectures or your class, that's why you are here. So let's get started. What is hydration? Hydration is a common term mostly used in organic chemistry, but in this video, we're looking at hydration in an inorganic way when we take an ion, how it gets coordinated with water. So over here it says it is interaction between a gaseous ion and water such that the ion becomes coordinated or surrounded by a sheet of water molecules. So let's take something like sodium chloride. Now when this plates will have sodium plus and chloride anion. So how will this, if this is in a gaseous form, how is it going to behave in water? So when you put this in water, you have sodium, this positively charged, is going to be coordinated by water molecule. Now remember the structure of water molecule. The shape of water is V. It's having two hydrogens attached to it and two lone pairs. And as a result of that, we see that the oxygen becomes partially negative and the hydrogens become partially positive. So we say this kind of molecule is polar. So what happens when sodium goes into water? Because water is polar, the oxygen will come closer to sodium where it is partially negative and this side partially positive, so there's going to be a weak interaction, probably dipole-dipole interaction between the sodium atom and the negative portion of the water molecule, which is the oxygen. Remember, these sides are partially positive. So water molecules will come and surround this positively charged sodium atom. So we have this dipole-dipole interaction all around here, very weak bonds. However, they'll coordinate the sodium. So if this happens, we'll say that the ion has been coordinated or surrounded by a sheet of water molecule, and this is what we call hydration of ions. And what about the chlorine? The chlorine is negatively charged, Cl minus. So probably you expect the positive side of the water molecule to come closer to it because these parts are partially positive, partially positive, partially positive, partially positive. So that's what is going to happen. Chlorine will also get coordinated by water, but this time it is a positive side of the water molecules that will get attracted to the chlorine because it is negatively charged. So basically that's what hydration is when we're talking about ions. Now what is hydrolysis? Now we'll be focusing more on hydrolysis. Hydrolysis over here, it says it is the interaction between an ion and water such that the OH bonds, take note of this, the OH bonds are broken, resulting in the formation of excess hydrozonium ion or hydronium ion H3O plus, which will cause acidity, or excess OH minus hydroxide or hydroxyl anions, which will cause alkalinity. So what does it mean? Okay, so for hydrolysis, let's take it step by step. We have two types of hydrolysis. We have what is known as cation hydrolysis, and then we also have what is known as anion hydrolysis. So what is cation hydrolysis? Let's come down here, pick. So cation hydrolysis. Now there are some few things we have to take note of. This cation hydrolysis, firstly, it will lead to the formation of H3O plus. So this one results in the formation of H3O plus. That means the solution becomes acidic. Okay, solution will become acidic. So let's take something like ammonium. When you have a cation such as ammonium, which is NH4 plus, NH4 plus in solution, what is going to happen is that you end up having NH3 plus H3O plus aqueous. So you find out that the ammonium is losing a proton to water molecule, which is forming H3O plus, and it's producing NH3. However, what we are having in excess in the solution is H3O plus, which will make the solution become acidic. Okay, so that is cation hydrolysis. The solution becomes acidic. Okay, all right, what about anion hydrolysis? Anion hydrolysis, this one, what you have to take note of is that it produces hydroxide ions. Produces hydroxide ions in solution. And once you know that there's a hydroxide ion, we should know that the solution becomes basic. Solution becomes basic. Okay, so what can we talk about? Let's take something like ethanoate. Ethanoate, when you take ethanoate, CH3 COO minus, and you put ethanoate, when it is dissolved in water, you have this, and then the water is going to act as the acid. Okay, it's going to act as the acid and donate a proton to the ethanoate, forming ethanoic acid, CH3COOH, and then as a result of that we'll have OH minus in the solution, and this one is telling us that the solution is alkaline. So that is the difference between cation hydrolysis and anion hydrolysis. Cation hydrolysis and anion hydrolysis. So it is that simple. Cation will produce acidic solution, anions will produce basic solution. So what you always have to remember is that usually salts are formed, we know that salts are formed from the reactions of acids and bases. So you have a cation, you have the cation from the base and the anion from the acid. The cation from the base, so let's take something like sodium hydroxide and hydrochloric acid, HCl. So what happened? You have the cation, this is our base. The cation here is sodium, and the anion over here is chlorine. So we have chloride forming the salt. So this is our salt, and this is the acid, and then water, H2O. Okay, so when we take this salt and we dissolve it in water, we are looking at the effect of it. Okay, so it is important to take note of some few points which we are going to look at now. All right, the first thing we have to look at is number one. If the salt is formed from a weak acid and a strong base, there will be anion hydrolysis and the resulting solution will be basic. So if the salt is formed from a weak acid, let's take note of this, a weak acid and a strong base, a weak acid and a strong base, there will be anion hydrolysis. That's how to take place, and the resulting solution will be basic. Okay, so let's take a salt that is formed from a weak acid such as ethanoic acid, CH3COOH. This is ethanoic acid vinegar. And a strong base, sodium hydroxide. What is going to be the salt? The salt is going to be sodium ethanoate, which is CH3COONA, and then water. Okay, so this is our salt. Now what happens if this salt gets dissolved in water? Now this is what happens. Let's take the salt CH3COONA and then put it in water. Or a minute, let me just clean this. So we are dissolving the salt in water. We'll have the ethanoate CH3COO minus, and then the sodium plus. Now remember we said that anytime we have a salt of this nature, there's going to be anion hydrolysis. So when we look at these two species, which one is the anion? Definitely the ethanoate. So this is the anion. So what will happen to the anion? The anion CH3COOH in water will pick a proton from water molecule, and then it will produce ethanoic acid CH3COOH, and what we are going to have as a remnant is OH minus, and remember this is what's basic, and so the solution becomes alkaline. So always take notes: a source from a weak acid and a strong base will undergo anion hydrolysis in solution, and the solution becomes what's basic. The next thing to look at is if the salt is formed from a strong acid and a weak base, there will be cation hydrolysis, and the resulting solution will be acidic. So this time we are looking at a strong acid and a weak base, and what will happen? A cation hydrolysis, and the resulting solution will be acidic. So let's look at an example. Okay, so this time let's take a strong acid such as hydrochloric acid HCl, and then a weak base such as ammonia NH3. Now what is going to be the result of this? We'll form ammonium chloride. Okay, alright, so what will happen if we dissolve ammonium chloride in water? So let's take our salt, which is ammonium chloride, NH4Cl. When we dissolve this, what will happen? We are going to have the cation, which is ammonium ion, and then the anion chloride. Okay, so that is what we are going to have in the solution. Good. Now what will happen here? We said cation hydrolysis take place. So what is a cation? This is a cation, and this is the anion. So cation will get hydrolyzed, what will happen? The NH4 will donate a proton to H2O, and then we'll end up having ammonia NH3 plus H3O plus. So you can see that the result of this is that we are producing hydrozonium ion in solution, and you know what is Arrhenius' definition of an acid. When we have excess H3O plus in solution, then we say that the solution is acidic. So this is what happens when you have a sauce that is formed from a strong acid and a weak base. It will undergo a cation hydrolysis, and the resulting solution will be acidic. Good. Another thing to take note of is that salts that are formed from strong acid and strong bases do not undergo hydrolysis when they are dissolved in water. They do not undergo hydrolysis. So a strong base, sodium hydroxide, and a strong acid, hydrochloric acid, this will give us sodium chloride and water, H2O. When we take the salt sodium chloride and then we dissolve it in water, we'll end up having sodium plus and Cl minus in the solution. And both of these guys will not undergo hydrolysis. They will not undergo hydrolysis. They can get hydrated or you have water molecules surrounding it, but it will not rip a proton of the water molecule to make it basic, nor will it donate a proton to the water molecule to make it acidic. So how do we know what species will not undergo hydrolysis in water? I think the best we can do is to know what the strong acids and bases are. Okay, what the strong acids and bases are. So it is very important to know that we have about 7 strong acids, which include HCl, hydrochloric acid. We have HNO3. We also have sulfuric acid, H2SO4. We have hydrogen bromide, and we also have HClO3. We have HClO3. We have hydrogen iodide, and then we also have perchloric acid, HClO4. Okay, so let's take note of this. These are the strong acids, the very strong acid. Apart from these ones, we may have some moderate one, but any other acid is a weak acid. And then so these are our seven strong acids. And then we also will have to know what the strong bases are. So basically, the strong bases are usually the hydroxides of group 1 and group 2 metals. The group 1 and group 2 metals will include things like lithium plus, sodium plus, potassium plus, cesium plus, and the group 2 you can mention magnesium 2 plus, calcium 2 plus. You can mention strontium 2 plus. You can mention barium 2 plus. So all these ones, anytime you see these ions, salts giving us these ions, then you should know that these ones will not undergo hydrolysis. So the ions you have from these guys will be Cl minus, NO3 minus, SO4 2 minus, bromide, anion. All these ones will not undergo hydrolysis. Now the last thing we're going to talk about is that salts formed from weak acids. So this time we are looking at weak acids and weak bases will form a neutral solution. How is that going to happen? They are going to form a neutral solution. So let's see how that will happen. Now, if you take a weak acid such as ethanoic acid, which we are using most often today, ethanoic acid, and let's take a weak base, ammonia, NH3. What is going to be the product? We will have ammonium ethanoate, CH3, COO, and H4. So this is what we are going to have. What will happen if this dissolves in water? We'll end up having CH3, COO, and H4, giving us CH3, COO minus, and NH4 plus. Now, what do you think will happen? This guy here can undergo a hydrolysis as well as this one. Okay, this will undergo anion hydrolysis, this will also undergo cation hydrolysis. So what will happen if this one undergoes hydrolysis? CH3 COO minus plus H2O. We'll have CH3COO H plus OH minus, and then when we take the ammonium NH4 plus in water, we will have NH3 and H3O plus. Okay, so that's what we are going to have. So both of the ions, this one, the anion and the cation, will undergo hydrolysis, and as a result they will produce OH minus and H3O plus, and these two guys will just combine to give us water molecules again. So we'll have OH minus and H3O plus. So this our acid, this is the base, this one is going to be our proton donor according to Bronsted-Lowry. So we're going to have 2 moles of water. So at the end of the day, the solution remains neutral. So that's what happens if you have a salt from weak acid and weak bases. Both ions produced from that salt will undergo hydrolysis, anion hydrolysis and cation hydrolysis, and the resulting solution will be neutral. I hope you find this video useful, and if you do, remember to press the like button and also subscribe. And then in our next tutorial, we're going to look at some likely exam questions on hydrolysis. Thank you.